Miura saves fuel in a lot of ways. At first, it can be a little bit of it's a difficult explanation. If you look at the conventional measure of efficiency, boiler efficiency, you're dealing with what we call fuel to steam efficiency. But fuel to steam efficiency really is not an accurate measure of reporting overall boiler efficiency for a number of reasons. Basically, it's as if you were purchasing a car, but the automobile manufacturer was only publishing their highway mileage, but you were going to purchase that car and do nothing but city driving. So again, the standard measure for boiler efficiency is fuel to steam efficiency. It measures a boiler only at its maximum output, 90% plus capacity, and a boiler that's already been heated up. So there's none of the startup time or energy lost associated with extended startup times or extended cool down times associated with it. So basically, when Miura sat down in the early 70s to redesign or reinvent the boiler and try to create a more efficient product, what we did is we looked at the conventional technologies available, and we looked at all those areas where a conventional boiler loses efficiency, and we tried to improve that. For instance, startup time is a big killer for a lot of people who are running steam plants to this day. If your boiler takes an hour to heat up, what that means is for an hour you're basically consuming 100% fuel capacity. You're burning gas, but you're not producing a usable pound of steam. So that's an hour of waste. You don't waste that during the startup period because that gas, that energy is being stored in the water of a conventional, let's say, fire tube boiler. But when you shut that boiler down now, all that stored energy just radiates out into the room. So you can do a direct comparison with a Miura boiler to any of our competitors' designs. If the Miura is going to produce steam in 5 minutes from a cold start and our competitor is going to do it, a very conservative estimate would be 45 minutes. That's 40 minutes of fuel usage you've saved every time you've had to cycle the boiler on and off. Some customers, that's not a major factor. If you turn your boiler on January 1st and you run it till you're shut down December 25th, well, that's only 40 minutes of fuel in the year. But there's still a lot of customers out there that run, let's say, one shift a day or even 5 days a week. So they do have a shutdown once a week or once a day, in which case every day, every time you cycle that boiler, our boiler is going to save you 40 minutes of fuel consumption, and that can add up. Other advantages or other ways we save fuel are our purge timers, for instance. This is another area with the Miura small compact design we've been able to improve fuel efficiency. Our pre-purge timer, of course, a purge cycle is what's required by the ASME. Anytime the boiler is turned on, you have to run cold air through it first for a certain period of time to exchange basically 4 volumes of air. It's a safety factor in case your gas valves are leaking. Well, the Miura can do that in 10 seconds. Our competitors are typically at the 60 to 90 seconds. So in a situation where you have a boiler that's having this cycle, maybe during low load periods or when a plant is idling, the Miura boiler, every time it has to cycle on, is only losing 10 seconds of cold air going through the heat exchanger versus the competitors at 60 or even 90 seconds. So direct savings again from the Miura boiler product line. Third, maybe also as important, is the fact that what we do is modular in design. So we typically aren't going to go in and install one single large boiler. We're going to install modular boilers. So for a 600 horsepower load, we'll put in 3 200 horsepower boilers, which allows us to turn on and off boilers as needed and only run the horsepower that you need to carry the load on any particular day or hour of the day. And then during the periods where you have high turn downs or low load periods, we're turning off those other boilers and allowing them to go cold. And that basically reduces the radiation footprint of your powerhouse. So of course, as a boiler is hot and it's producing steam, you're wasting energy, and that heat is radiating into the environment, and it's a loss of energy. So the smaller you can keep that radiation footprint, the higher your resulting efficiency will be.